Hi everyone, Mr. Rivetto again for Unit 9 now, which is going to be our first of a couple of units on trigonometry. So right now we're just doing some intro stuff, really learning what trigonometry is and about the basic trig functions. And we'll get into more depth, like graphs of the trig functions in Unit 10 and using them a little more beyond them. But just as an intro, we have lesson 1 here. So as we discussed last year in algebra, or 2 years ago, and in geometry, a trig ratio is just the ratio between sides of a triangle. And the three most commonly discussed ratios are sine, cosine, and tangent, which we abbreviate as sin, cos, and tan. Please, when you see those, though, remember it's sine, cosine, and tangent. Truthfully, nothing makes me feel like I'm failing more as a teacher than when I hear sin, cos, and tan. So yes, those stand for sine, cosine, and tangent. And they're based on an acute angle in a right triangle, which we're going to refer to as the reference angle. So in the triangle to the left here, we're going to use angle R as our reference angle here. So it's a good idea to always mark your reference angle. I usually put just a little arc there so that I know what I'm looking at here. And based on this angle, the trig ratios here, by definition, the sine of angle R, sine R, equals the leg is equal to the leg that's opposite angle R over the hypotenuse of that right triangle here. So looking at this triangle here, the leg that's opposite angle R is this side ST, which just has length little r here. And the hypotenuse, of course, is side SR, which just has length little t there. Right? And we know that's the hypotenuse because it's across from the 90-degree angle, the one that's right over here, right, angle T. So similarly, cosine then is the leg that's adjacent to the angle R over the hypotenuse. And we see here the side that's adjacent to angle R is side RT, which has length little s there. And of course, the hypotenuse is still t again. And then the tangent of R is equal to the ratio of the leg that's opposite to angle R over the leg that's adjacent to the angle R, or just little r over s here. So if you have those values for little r, little s, and little t, you can just plug them in, and we'll have the values here for sine, cosine, and tangent of that triangle that we just saw there. Right? So it kind of looks like it's a lot of information, but as I'm sure you remember, we have a little mnemonic to remember what goes with what here. So we have the little phrase or the mnemonic SOH-CAH-TOA, right? SOH-CAH-TOA. Everyone likes saying it. We all remember it here. And what it stands for is exactly what the trig ratios are. So the SO part is sine of your reference angle, sine of what we'll call theta here, right? Sine of your reference angle is equal to the side that's opposite that angle over the hypotenuse of the triangle. Similarly, cosine of that angle is the side that's adjacent, A, over the hypotenuse. And TOA, tangent, is the opposite, O, over the adjacent, A, right? So since we always think about these trig ratios as they are referenced to a right triangle here, we need to be able to label the sides of the triangle properly. It's extremely important that we can get the labels of the triangle, the labels of each side in the triangle correctly. Otherwise, we're not going to be using the right ratio, and our answers are going to be wrong here. All right, so let's just take a look at a little example here. Let's just sketch a triangle like we saw in that case. I'll call it triangle ABC. All right, so we have angles A, B, and C there. And angle B, as I've drawn it, is the right angle there. Okay, so the first thing we want to do is always label what the hypotenuse is, because it's the easiest one. It's always the one that's across from the right angle. And we can figure that out because that little box that represents a 90-degree angle, which is a right angle, is kind of like an arrow. It's pointing to our hypotenuse here, right? So in this case, side AC would be our hypotenuse. I'm just going to put a little h there, right? And let's say here, angle A is our reference angle. You want to draw an arc like the one I just did above, or like you would do to mark congruence in geometry, that starts from the hypotenuse that we just found to the next side that you hit. We're just drawing a little arc. So starting from the hypotenuse here, we're going to draw it over to here. Okay. Looks like the iPad thought I was drawing a straight line. Okay. So we'll just draw a arc. Look kind of like a 90-degree angle. Sorry, I'm kind of squeezing it in there, right? So we draw that arc, and the side we hit there is the adjacent side, right? So I'll say ADJ for adjacent, just we're not confused with the angle A there. All right, so that's one way we can figure out the adjacent, but also just remember what these words mean. Adjacent means next to, right? It means that it's right next to this side here. So if we're looking at angle A, if that's our reference angle, the side next to it is side AB, right? We already know what the hypotenuse is. That's next to it too, but that's the hypotenuse. It gets its own special treatment here, right? So the only other side left that's next to it is side AB. And then similarly, the last one left is side CB here, which is our opposite side. And again, what's in a name here? Opposite means away from, right? If we have one side that's next to it and we have one side that's away from it, we just got to look at the picture and figure those out, right? So if you can't figure that out, though, if that doesn't really vibe well with you, you can always do a little trick with the arrow where we're starting at the hypotenuse like we did here, drawing a little arc, and that first side we hit, that's going to be our adjacent side, right? So it's extremely important that we can do this right here. So we're going to practice that a little bit in our next examples, because otherwise we can't find our missing sides, right? We can't find the values. We can't use these trig functions to give us any information here, right? But in order to be able to do that, like we said, we first need to mark our reference angle. And then, as you can see, in step 3, we place the appropriate labels on each side. I kind of skipped over in step 1 there. Step 1 is kind of more like step 0. When you're working with degrees, the angle measures in degrees, you need to double check that your calculator is in degrees here. So just going over to a calculator, this one at least sort of looks like all your TI-84s or whatever, has the same buttons. The way you check that, once again, is you go to mode, which is right up here. And right on the third one, it says radian or degree. So I need to go down and highlight degree. I'm going to hit enter there, okay? Anyway, though, getting back to our problem. So we make sure it's in degrees, we've labeled our reference angle, and once we have the appropriate labels on each side, step 4 is kind of like a visual cue here. Let's label the two sides we're working with here. So the sides we're working with, it's always going to depend on what's some side that we have information on, a length of, and what's the side we're looking for. So in the figure that we see over to the right here, our reference angle over here, theta, was 60 degrees. And of course, the side that's away from it there is the opposite, and the side that's next to it is the hypotenuse. We have information on the opposite and the hypotenuse. So I got to think about SOH-CAH-TOA and what relates opposite and hypotenuse. So SOH, so, is opposite and hypotenuse here, right? So based on those two sides then that we've circled, we determine the appropriate ratio. So like I just said, in this case, it's sine. And then we're just filling in sine of theta equals opposite over hypotenuse. Well, the opposite side we labeled as 6. The hypotenuse, that's our unknown. And then theta is our angle. It's just 60 degrees. Now, we don't know what sine of 60 is exactly right now, but that's where our calculator comes in, right? So we can just figure out that that's, use that in our calculator to find that value is 0.8660. And then we're just solving a simple ratio that we have over in this line over here. All right, so we have 8.660 equals 6 over x. We got to solve for x here, which means we multiply both sides by x to get the x out of the denominator. Then we'll have to divide by the 0.8660. And in this case, we'll get x is approximately 6.93, or our hypotenuse is approximately that much. So let's practice one more, a couple more examples, actually. Let's look at number 1 here. First thing we got to do, well, we're in degrees already. We checked that. So we're going to mark our reference angle, 40 degrees here, right? And we need to label our sides. So in this case, the hypotenuse is always across from the 90-degree angle. So we don't have any information on that. We're not seeking information on it. We don't really care. Now we got to label the other two sides. As I drew the arc, this side over here was the first one I came to. So I know that's my adjacent side. And this side with side length 11, that's our opposite side, which again, we can tell because that one's away from the angle. It's not touching it. It doesn't help form the angle. It's not next to it, right? So looking at this, we have an opposite and an adjacent. I think about SOH-CAH-TOA, I need OA, SOH-CAH-TOA, right? So that's going to say that tangent of 40 degrees, just plugging these in, is equal to the opposite over the adjacent. And now we're just working this out. So tangent of 40 degrees equals the opposite side's 11, the adjacent's x. I'm going to multiply both sides by x to get that x out of there. Then I'm going to divide by the tangent of 40 on both sides to get the x all by itself, because remember, that's what solving for a variable means. And I'll get x is equal to 11 over the tangent of 40. And you'll notice I did it a little different in this example than the one from the above. I didn't put in the decimal value for tangent of 40 yet. That's fine too. You can wait to the end. So now we just got to figure out this ratio. I'm going to go to my calculator. All right, and we said that this is going to be equal to 11 divided by the tangent of 40 degrees. Enter, which it tells me is 13.109. So I have here that x is approximately equal to 13.109. Final answer for number 1. Okay, let's do one more here with number 2. Again, we mark our reference angle in that case. So that's what we're looking at here. Our hypotenuse is always across from our 90-degree angle. Since this is our reference angle, that makes this side the adjacent, and this side is the opposite in this case, right? So I have information on H and O. So SOH is sine of 30 degrees equals to SOH-CAH-TOA, right? SO over H is X over 10. Or in this case, just multiplying by 10 on both sides, I have 10 times the sine of 30 is equal to X. I use my calculator. In this case, I actually know the sine of 30 is just a half. And we'll figure that out in a future lesson, but we can figure out that X is equal to 5. And again, I just plugged into the calculator. I just happened to know that one, so I skipped over to keep it a little concise here. All right. So that's how we can use our trig ratios to solve for another side when we have an angle. But we can also sort of work backwards. Let's say we have information on 2 sides, or even all 3 sides. That's even better. If we have information on the sides, and then we can sort of work backwards and figure out information on the angle measurement. We could figure out the missing angle in the triangle. But in that case, we need to use what's called the inverse trig functions, which on your calculator, and they're almost always written as such. They're written as sine to the power of -1, it seems. I always just read that as sine inverse or inverse sine, cosine inverse, tangent inverse there. The -1 in the exponent means inverse here. Now, one quick note, that -1 power does not mean the reciprocal. It doesn't mean 1 over the sine. That's actually a completely different function, which we will also talk about in this unit. It means sine inverse, and there's a separate button for it. So to use these functions, we're going to need to hit the second button and then hit sine, cosine, or tangent. So just to see what that looks like on the calculator, if you see in blue over the, if you look at your calculator or even on mine here, over the sine, the cosine, and the tangent buttons, in blue it says sine to the -1, cosine to the -1, tangent to the -1 there, right? Or sine inverse, cosine inverse, tangent inverse, which is the inverse trig functions there. And recall, to get those functions on your calculator, you hit the second button first, and then you would click the button, right? So now it says sine inverse of some angle measurement here, right? And then we would plug in whatever our ratio is. The only difference here is now we're solving for theta. We don't know what that is. And what we put into the parentheses in our calculator is the same ratio that we find. So we still set up our ratios the same way, but what we plug in are the 2 values we have in this case. So our steps kind of follow almost exactly the same. We need to be in degrees. We mark the angle we're trying to solve for here in this case, and we have to label all of our sides, right? Once we label our sides, we need to figure out which trig function we're using again, and then we just plug into our calculators in this case. So here, this theta is our reference angle. So, sorry, I'm just trying to get the highlighting function, but it seems like it's not working right now, so that's fine. So this theta over here is our reference angle, which means the side next to it is the adjacent. That's side length 10, and the hypotenuse we know is always across from the 90-degree angle. That has measure 15, right? So circling those 2 things that we have information on, we have the adjacent and the hypotenuse. Thinking about our SOH-CAH-TOA, that's going to be cosine in this case, right? But since we have the sides and we're looking for the angle, we actually use the inverse cosine in this case. So but it's the same idea, right? It's still adjacent over hypotenuse. So in this case, 10 over 15, but what we plug in is the 10 over 15 to the inverse cosine function, and we end up with 48.2. Right, so then we just, this is basically just saying you set up your problem and you plug into your calculator there, okay? So it sounds a little confusing right there, but it's very simple. It's pretty much the same idea as what we just did, except we just have to hit the inverse button. So let's practice that with a couple of these. Let's look at number 1 in this case. This is our angle theta here. So let's mark off what's going to be our hypotenuse. That's always opposite the 90-degree angle. So that's that one. Looks like we're not going to be using hypotenuse here. We don't have any information on that. The side that's next to it that our arc touches is our adjacent, and the side that's away from it, opposite to it, is our opposite side. So we have information on the opposite and the adjacent. Thinking about our trig functions again, what relates O and A? Well, that's TOA, right? Tangent of angle theta is equal to the opposite over adjacent, or in this case, theta is going to be equal to the inverse tangent of TOA, opposite over adjacent, 8/6, right? And then we just need to plug this value into our calculator. So I'm going to go over to the calculator again, and I'm going to hit second tangent, and that's going to give me tangent inverse of 8/6, and hit enter, and I get 53.13 degrees. So I get theta equals 53.13 degrees. It says round it to the nearest 10, so it's 53.1 degrees in this case. Right, and it's going to be the same idea. So let's do number 3 as well. This is our angle here. We label our sides. This is the hypotenuse. The one across from us is the opposite. I'm not even going to bother labeling the adjacent because clearly we don't have that, right? So we have O and H. I think about SOH-CAH-TOA, which means I have that theta, since I'm looking for an angle in this case, O and H is sine, but it's not just sine, it's sine inverse, since I'm looking for an angle of the opposite, 8 over the hypotenuse, 10. And I plug this value into my calculator. I get theta equals second sine inverse of 8/10, which is also 53.13. Or just rounding to one place, 53.1 degrees. So those are actually the same triangle in this case. Those are a special right triangle. So that's it for the intro to our trig functions here, how to find sides given an angle and another side, and how to find angles given two sides, right? Remember, when we're solving for sides, we use the regular trig ratios, the sine, cosine, tangent, and when we're solving for angles, we use the inverse functions, sine inverse, cosine inverse, tangent inverse here. That's going to be all for lesson 1. We're going to build on these skills in the following lessons here, but that's it for now.